Yeah, it's really great to see everybody, and thank you for joining for another edition of the TMLS Micro Summit. This one focusing in on NLP, and I know that for some of you, it's some familiar faces. And I'm glad to see some folks in the crowd that I recognize, some who have spoken in the past, which is great, and some new faces as well. So all are welcome, and I really appreciate you guys joining. I know it's not in person, which would have been preferred. I think at this time, it's something that I really miss, but hey, this is the best we could do. So it is good to see everybody here, and I'm really grateful for the speakers today for taking the time to join. You'll see very quickly that they have some really interesting backgrounds, some really interesting work that they've done, and they come with a wealth of experience and knowledge. So I'm really grateful for having them share with us today. For those, just a quick housekeeping note, who haven't been to any of our events in the past virtually, Hopin is a platform that we'll be using tomorrow. So make sure you have a link for that and you've registered. The platform is pretty dynamic. You get a chance to meet people, see who's attending, message them, private message them, or message in the chat the speakers, etc. So there's a lot of different ways in which you can connect and be engaged for tomorrow. For today, the same. Expect the same. So you can message in the chat if you have any questions, and if there are any questions, the presenters here today can take some time to address those. And that's really the beauty of these sessions, the workshops, that I find are actually easier than in person. There's no specific hard stop, right? So, I mean, not only in terms of just time, but you know, we don't have to put up our hand and wait and ask questions and so on. Just throw it in the chat and it's okay. And don't worry about any silly questions or questions that are uninformed. We're all at different trajectories and paths of our learning and growth, right? So yeah, feel free to ask that question that maybe you're not sure of. This is how we get the best value out of these sessions. Yeah, but before we let our two presenters kick things off, I just want to give a quick intro. First of all, Veronika. Veronika is a director, data science at Loblaw's data science and analytics team with over 5 years experience building end-to-end data science solutions and applying machine learning and deep learning algorithms to cutting-edge AI-enabled products to market. Her main focus for the past 4 years has been natural language processing and its applications on problems across industries such as legal, financial services, retail, health, and wellness. And at Loblaw, she manages a high-performing team of data scientists and leads initiatives bringing best practices in state-of-the-art thinking. And if you've, at this point, had a couple opportunities to hear Loblaw's present, in terms of what we've been doing in the sort of retail field in Canada, they're really cutting edge. And I know speaking with Rich, he's talked about this, how COVID has really amplified some of the projects, the amount of data and the ways in which they're approaching that in Canada. So anyways, side note, but if you get a chance to speak with the team or speak with Veronika or Sima at some point, I encourage you to do so because it's doing some really interesting things. And in terms of how it goes in Canada when it comes to the retail and grocery store chain applications, it's really forward thinking. I'm really proud of the team. Second presenter, sorry to get distracted. Sima is a senior data scientist at Loblaw Limited, and she has a PhD in computer science, focusing on detecting hateful speech in social media using NLP techniques and different NLP techniques. She has more than 8 publications in top conferences such as ACL, KDD, EMNLP, and NeurIPS. Sima has 5 years experience using machine learning techniques in research and 2 years of experience building and deploying NLP solutions to solve inference challenges at scale. In Loblaws, she's been working with different internal and external stakeholders such as the demand forecasting team, the shelf price optimization team, really cool challenges there, price optimization, and health and wellness team focusing on different projects. So with that being said, I will pass you over to the hands of Sima and Veronika. Thank you so much for joining. I'm really grateful to have you guys here. I'll let you kick things off and I'll take my mic and mute myself. But yes, over to you.
Thank you so much for introductions. So as you heard, my name is Veronika Feherova. I am leading AI/ML COE team at Loblaw in data insights and analytics team. I'm here with my senior data scientist Sima from the same team. We work very closely together on a lot of NLP work within the AI&A. And today we would like to talk about the importance of data annotation for NLP. So today's agenda for our workshop will be, first, we're going to look at where the data annotation sits within machine learning model lifecycle. And we look at some training data preparation and best practices and lessons learned for what we learned during our projects with that in the past couple of years, focused on NLP. Then we're going to look at some inconsistent labeling and how that impacts model performance. Then Sima will share an interesting data annotation use case she worked on. And we're also going to look at some data annotation tools and accelerators that can help you really efficiently speed up the process of data preparation, training data preparation for NLP tasks and projects. Let's start with the data annotation and machine learning model lifecycle. What you can see on your screen in front of you, it's the machine learning model lifecycle. I'm pretty sure you've seen this process or this diagram of some sort of form, similar form before. This is what we also follow in Loblaw and across multiple teams. We always start with our business problem definition, which is very important to understand what is the business impact of the problem that we are solving and have a clear idea what is the goal that we are trying to solve. Once that is clear, we go to the project scoping when we specify what is the roadmap and timelines. What type of data do I need? Who do I need to talk to from the business stakeholders to get the input that I need? Once we have that, we move to the research stage. Sometimes we do need to do our own research to figure out maybe which techniques to start with to tackle certain problems and prioritize what we want to start with. From the research stage, we are moving to data collection. So we identify the data sources. A lot of times we have multiple data sources. So we need to talk to the data owners to actually get an access to the right data that we need. From the data collection, we are moving to the training data preparation. That's where our entire pipeline around data annotation begins. So we spend a lot of time on training data preparation of identifying what actually I need to annotate, how I annotate, and building the entire process around that. Once I have a training data, let's say the first iteration, I go through the model training and model evaluation. After evaluation, a lot of times you need to go back to training data preparation. Maybe you need more data. Maybe you need to annotate it a little bit differently. Sometimes we need to go back to data collection. Maybe I find out that I don't have enough data to support certain tasks. So I go back and I need to collect more data from more data sources. If I find out that my techniques may be not the best, that happens sometimes, I can go back to research and try maybe different techniques. And sometimes we actually go back even to a project scoping. Maybe we did not realize that this project actually might take way more effort to do because we were not sure what type of data sets we had and we didn't know exactly what is in these data sets. Maybe we need to go back and do the project scoping again. So once we feel like our model is good enough, signed off by our stakeholder, usually it's someone from the business side who gives us a green light. Okay, yes, this model is performing to my likings, to my expectations. Then we go to the model deployment and monitoring. As you can see, there is a lot of time spent on data preparation. And even Andrew Angus is saying, if 80% of our work is data preparation, then ensuring quality is very, very important work of machine learning teams. Let's have a look at what is actually a data annotation in NLP. So in order to train a supervised model that can recognize patterns in text, that can identify entities, classify sentences, find sentiment, find relationships between entities, we need to provide the model with examples of how that relevant information looks like. And that labels, that relevant information, it's called annotations or labels. The systematic process of identifying and adding these meaningful labels and informative labels to raw data is called data annotation. And the corresponding labels that are creating are being called a ground truth. As an outcome of this data annotation process, we get the actual training data set that should contain a good number of ground truth examples in order for the model to learn what it needs to learn in order to identify and extract the information we need. Let's have a look at approach for training data preparation. The diagram you can see in front of you is kind of our process flow that we do when we are building a model and mostly focusing on the data annotation process itself and training data preparation process itself. We start with identifying data sources. So once the business problem is defined, we need to look into what type of sources we have and analyze the data available for modeling. After that, we look through the sample, selecting a sample data set for analysis. This is very important because sometimes you might have so many data points, so many different data sources that you don't really know what is in your data. So it's always good to select the sample and maybe try to make the sample the most representative as possible, as it is possible to see what do I actually have in my text data. After I have my sample data set for analysis, I form a data annotation team and I start annotating the data set, identifying information that I want my model to learn. This is an important process that results into building an annotation guidelines. We usually appoint annotation leads who help to build the first draft of the data annotation guidelines. And these guidelines will be regularly updated as we are going through the training process and annotation process. After we have this sample data set annotated and we kind of understand what is the language, what is that we are dealing with, we can go ahead and select the data set for training. So expand that sample data set to something a little bit bigger and sufficient for our training, or at least the first first round of training. So we do leverage the knowledge that we got from the annotating of the sample data set. Annotating data set for training is the next step. So this really requires a well-streamlined process of data annotation, leveraging a team of annotators. A lot of times you do need domain subject matter experts to help really define what is the right label, what is right, what is wrong for a specific task. The areas where this is important is usually in a medical text or a legal text. After the annotation, let's say the first round of annotation, there needs to be a QA layer. So we do leverage a QA annotators, our reviewers that will go through what was already annotated and identify if there were some missing labels or inconsistent labeling. This can be done through the annotation team itself, but also using some automated techniques, for example, looking at text similarity. That helps to identify inconsistent labeling. And after QA, I can go ahead and start my training. So as most of you know, model training is an iterative process. So once the data set is validated, data set is split into train, test, evaluation sets, and we are going through the iterations of training. We will be updating, usually, that's how it usually is, that you have to update your training set, test set, validation set as you go through the training and you do a proper evaluation of the model. You will recognize that there are some nuances that are not captured in your data set. So you have to go back and maybe add more examples or do the extra annotation work. To do that, we usually use false positives and false negatives analysis. So I really look at the output from the model, and with the help of annotators, I'm looking through what was caught as a false positive and what our model was not able to identify, so false negatives. Maybe let's have a look at some challenges that we had when we had to select sample data set for analysis. Many times we have high volume of data coming from various sources in multiple formats. Now, what do I do? How do I start to even analyze my data? What worked for us is to, yes, you select randomly a subset of text documents from each source. Even without opening the file itself, you can use a metadata information such as file size, file format, sometimes even file name, to kind of bring as much variety into your sample data set to cover your bigger data set and to understand what is in your data. A lot of times, with the help of the subject matter domain subject matter experts, we can identify some key phrases or key words that could help to find the relevant text and relevant content in our data set. Now, if I have a sample set, that's nice. But now what do I do in order to get the actual data set for training? So I need to expand my sample set. And a lot of times we ask questions of how much data do I actually need to train a model to understand the patterns in text? Do I have the right data? So the approaches that work for us is, of course, we do leverage the knowledge from initial annotation of a sample data set. So I know what already I could expect from my data set, from a bigger data set, and how to find that relevant information. And we analyze the labels of the annotated text and to understand the complexity and variability in text. Number of examples of each label really depends on the language variability and consistency, as well as task itself. More examples are usually needed when my language is very consistent or variable, or also when I'm training a model that is recognizing entities or extracting entities versus text segment classification tasks. That is kind of from our experience that we really had to bring maybe twice as many labels in for entity recognition compared to the text segment or sentence classification tasks. Now, let's have a look at the actual annotation process. So how to annotate our data. So looking at the annotation of a sample data set, what does that mean? And why is it important? It's really important to understand the semantics of text and also align on annotation strategy. By looking into the small data set, I can understand what are the nuances, whether there's some ambiguity in my text, and how to actually annotate the information so the model can learn. It is essential for creating annotation guideline, and in order to add some examples to the annotation guidelines of what is a good label, what is a bad label, how wide the label should be, and others. This process also helps us identify the annotation leads. It's always good to have, it's kind of good practice to have appointed annotation leads who kind of overlook the annotation process together with our data science team, and they can guide the other annotators. So this process also strengthens the relationship and collaboration between data science team and annotation teams. On my past projects, we actually did work so closely with annotation teams that sometimes we would actually even sit in the same room. Moving on creating and updating annotation guidelines. So the annotation guidelines contain, first of all, the explanation of the task itself. That needs to be clear to the annotation teams, and so they need to understand what the goal is and why we are doing this. It also contains a breakdown of different types of text documents, so different types of data sources that we have, and the detailed annotation instructions for each label with a lot of examples. These guidelines need to be regularly updated and usually reviewed by the business stakeholder or domain subject matter expert to make sure that everything that is written in the guidelines is still valid and the approach is correct. When we are moving to the annotation of the training set, the entire training set, it's good to split the data set into multiple batches and have multiple annotators annotate the same batch for the same batch of data for the same labeling task. This way, we can really see in which cases we have all annotators labeling the same thing, in which cases we have some inconsistency, and we can go and drill down and analyze these inconsistencies and trying to understand, okay, maybe the annotation guidelines are not clear, or maybe this is something that needs to be explained a little bit better. So by doing this, we do identify labels where annotators disagree, and types of classes which we don't have sufficient representation in text. That happens as well. Maybe I start with an idea what I'm going to be annotating based on the sample data set, and then I bring the bigger data set for training, and I realize, oh, but I don't have enough examples from this particular label. So usually we have to go back and maybe enrich the data set, maybe in some kind of a clever way to make sure that the new data set for training will contain enough examples. QA and validation of annotated data set is so important. It's so important to have a team to kind of go through what was annotated, investigate the annotations, go through the entire data set if possible. If it's too big, we usually select the random sample and go through what was annotated. There are some techniques that data science teams can leverage in order to identify inconsistent labeling. So, for example, you can use a text similarity on the embeddings, and using cosine distance and cosine similarity, you can find some mislabeling that happened. For example, I have one sentence. I have two sentences that are very similar context, but only one of them was annotated and the other one was missed. Using these techniques of text similarity, I can identify this mislabeling and prevent model from learning something that can confuse the model itself. After we have the QA and validation done, we go through the training. So we usually do split it and train, evaluation, and test it. But as we go through the training, we might need to enrich all those sets. And we are trying to keep train and test set kind of a similar distribution of the data that we have. So if I enrich training set of completely new examples that the model never saw, I also have to look at the test set and maybe update it accordingly. As part of the evaluation of the model, as I mentioned already previously, when we're looking at the whole diagram, we do analyze false positives and false negatives. It's very important to establish what false positives means. If you look at the example on the screen, in this sentence, we see that acute pancreatic attack with critical blood vessels levels was annotated as ground truth. But for example, what if our model identifies the prediction 1 and prediction 2? Now, do we consider these two predictions false positives? That means that our ground truth is a false negative, or do we create some kind of threshold of between what was predicted and what was a ground truth through maybe intersection or reunion of the text? This all comes down to agreement between your subject matter expert or a business stakeholder or stakeholder who is signing off on the results coming from the model. We usually generate a list of false positives and false negatives for each class that we have, and leverage annotation teams to kind of go through it. Go through maybe a lot of times, actually, we find that model is clever and even sometimes more clever to identify some information, some text segments, some entities that were actually missed by the annotation team. That happens. So exactly, as stated here, this process helps identifying labels missed by the annotators and is targeted to improve performance of the model. And now I'll let Sima to go through some inconsistent labeling and show you some examples of it.
Thanks, Veronika. So the first task that we kind of mention here is inconsistent labeling in NER. So in NER task or name entity recognition, we would like to identify some entities that are of our interest, and we would like to find them in a piece of text. So it could be a sentence, it could be a paragraph or a document. So here in this example, you would see that we have a list of tags, for example, person, title, and country, and we would like to kind of label this piece of text using these tags. So as you would see, we have 3 annotators, and they annotate one line in a very different way. So in the first sentence, the President of the United States, Biden, the first annotator identify from President Biden as the person. In the second sentence, the second annotator, the President of the United States, Biden, we have 2 tags. One of them is President of the United States as title, and the other one is person, which is Biden. And in the last example, you will see that the third annotator use all the 3 tags: President, the title, United States, country, and person as a Biden as a person. Next slide. So it is always important to have a checklist when we are focusing on a specific task. Usually having more than 1 annotator is recommended. It's absolutely crucial to have more than 1, but the kind of how many, like more than 1, but is it going to be 3 or 5 is really dependent on the task. We need to pay attention to the disagreement in the labeling process. Disagreement is not always bad. Sometimes it is a signal that maybe the annotation instruction is not well defined. Maybe some of the sentences, they are vague, or their semantics is not in a way that help annotators to really find the right label. And examples are not always equal. Sometimes we have different classes or categories that we would like to find a specific label for them. But the examples that are in one category, for example, they might have a vague meaning or a different semantic. And it's always good to keep revisiting labels periodically, even after we are done with this task. Mainly because maybe the meaning of the labels would change. Maybe we change our mind about the number of labels, or even the name of the labels. So here I'm going to talk about some inconsistent labeling in the second task, which is a slot filling task. So usually we have this in the dialect systems where the user has a specific queries, and we would like to have to extract a specific tokens to retrieve and answer, right, and help the user. So for example, in example number one, do you mind checking my savings? You would see that we are interested to extract the kind of tag for the slot account, right? And you would see that labelers incorrectly kind of choosing kind of checking, right? Which is the incorrect label. For example number 2, we have 2 examples, 2.1 and 2.2. Buy tickets for January 14 in 2020 and scheduled on the 20th of December 2016. Here we have the problem that we call it chop and joy inconsistency. And it is basically in 2.1, you would see that the data slot is applied to one continuous kind of token span. But in the second example, the data slot is applied to individual attribute, right? Which is the day, month, and the year. For example number 3, transfer $30, please. It's just the wrong label consistency. $30 is marked as a slot, but with account, right, instead of amount. So this would be usually as a result of a typo or misclick when using the annotation tool, or maybe misunderstanding of the slot. Example 4.1 and 4.2, we have two examples. How much Canadian dollar is 1 Mexican peso, and how much is the rate from American to Canadian. So in this example, you will see that much is identified is in 4.2, but it is not identified in 4.1. And also Canadian dollar is not amount, right? So it is kind of wrong label as well. So after like you have a data set and you went through the process of labeling your data set, there are different measuring techniques that you could use to check the consistency. You could use Cohen's kappa, Flace kappa, and Krimper-Dobbs alpha. So they have like subtle differences. Cohen's kappa, for example, is to calculate the interreliability when we have two annotators for categorical items, and it kind of identifies how frequently the raters are in agreement or disagreement. Usually the score for Cohen's kappa is between -1 to 1, and 0 means kind of random agreement. Below 0 means no agreement, and between 0 and 1, it means agreement, but we have different interpretation based on different threshold between 0 and 1. So usually, for example, from 0.8 to 1, it is almost perfect agreement. For the Flex kappa, is the extension of the Cohen's kappa, and we have the kind of assumption that the raters are independent, and when we have multiple annotators, it's better to use these metrics. And the last one, it's useful when there are multiple raters and multiple possible ratings, and it's very flexible in terms of the missing values. But I have to say that, like, choosing, so sometimes for different tasks, the matrices that you are using is very different. So maybe, for example, for clinical diagnosis, high kappa score is necessary, but maybe for social science work, moderate kappa score would be sufficient. So it is first task related. And the second thing is that sometimes we need to use multiple matrices to kind of come up with the right kind of agreement, disagreement sense. Let's talk about data annotation use case. This work is related to my PhD work. When I started working on it in 2016, 2017, I went through collecting data sets related to this task, kind of identifying the hateful speech or harassment tweets. So I had I identified two tasks. The first one is classifying tweets into harassment versus not harassment, and then we categorize harassment tweets into more granular kind of categories. So we released this data set in 2019 as a form of a competition. So in the next slide, I'm going to talk about my personal experience with annotation process. So I figured that I would like to kind of work on this task. I had my supervisor support, so I started with data collection, which is the first task. So for data collection, I collected, I used a Twitter API, and I collected I could kind of collected just 1% of the tweets per day. So I started collecting data for a period of time. And then using a specific hashtags and mentions, and these hashtags and mentions, they come from social science papers, like, for example, Me Too or Men Call Me Things or something like that. In the next step, it was instruction creation. So I prepared the instruction using, again, social science work. After I finished the draft, I checked it with my lab mates, my supervisor, and then initially we recruited 12 students at the university to label about 50 data points. And we recruited from 2 different kind of genders to kind of understand how their views are different. And it was quite surprisingly very different. For this specific task, we see that they are kind of different interpretation related to a specific tweet or different biases. So after I was done with this step, I started doing crowdsourcing. So back then, I went through different kind of crowdsourcing platforms, and the one that I chose was Crowdflower. The current name is Figure 8. So basically, we decided to label each tweet using 5 annotators, and in the instruction for each of the categories, I mentioned the edge cases, false positive, false negatives, or we can say like a sample of bad annotation versus good annotation. In the next step, after we receive the labels for the tweets, we decided to check the quality of the annotation. So the first one was calculating the kappa score to check their inter-annotation agreement. Then for the batches with low confidence or low kappa score, we look into the samples in the categories with my colleagues from social science department, and we try to understand what is the reason that these batches, they have low score. Is it because of the semantic? Is it because of the instruction? Is it because of the annotators kind of understand it in a specific way? And then with the batches with low confidence score, we decided to relabel them again. And after that, we open sourced the dataset for academic community in 2019 in the form of a competition. So that was the kind of short overview of what we did. In the next slide, I'm going to talk about some of the annotation tools and accelerators. Next slide. So there are many different tools and accelerators right now. We are going to just talk about Vertex AI and Ducano, but there are wealth of annotation tools. Just feel free to dive deep into different of them and choose the appropriate one for your task. So starting from Vertex AI, Vertex AI is introduced in May 18, 2021, and it is one of the kind of services in GCP, and it supports different tasks in NLP, image processing, and time series. So it has a specific data requirements based on the task that you are interested, and these requirements are vary based on the task. So for example, for name entity recognition, the data requirements are as follows. For example, you must supply at least 50 data rows for your training documents and not more than 100,000. You must supply at least 1 unique labels and not more than 100. So each of the labels that we can use is like the they are between 1 and 10. And label names can be between 2 and 30 characters. So as you would see, there are certain rules and maybe limitations on the labeling name, the number of annotators, and also the number of data points that we provide for each task. So the first step using Vertex AI always starts with creating a data set. So if you kind of pay attention to the first snapshot, you would see we have image, tabular, text, and video. For the text, we have single label classification, multi-label classification, name entity recognition, and also sentiment analysis. So the task that we chose is text entity recognition. So after you create a data set, so basically in the first step, you just need to assign a name, right? And then create it. So usually it takes few minutes. And after that, you need to import the data set. So when it comes to importing data set, you have this possibility to import it from your computer. When it comes to importing data set from your computer, you could either import it in the form of TXT. For example, one line in one TXT document, or you can have all of your kind of data points or text in a JSON format. And you can kind of save them in different locations. It could be in cloud storage, it could be on your computer. So after you upload your data set, we go to slide 3, on the part 3, you're going to start creating your labeling task. So for the labeling task, you need to assign a name. The dataset is the dataset that you previously created, and you're going to have annotation set to. So automatically, I noticed that the name that it assigned is NERT. In number 4, you would see that we would need to set up labels. We have this option to kind of add different labels. For example, for this specific data set that we chose, we needed to have symptoms, disease, and so forth. After you kind of list all of the labels that you are interested in, you're going to have you have the option for customized labelers. So for the customized labelers, you have the option to choose labelers per item. So it could be 1, 3, and 5. You have this possibility to kind of make a name for the group that you are trying to kind of use to label the text. And then you're going to assign the manager, and it's basically what all you need to make a labeling task. In the next slide, you would see that I already uploaded the kind of data set, and the task is also created. You have this possibility to click on each of the rows. It expanded. You would be able to filter the labels and start doing the labeling process. The second tool that we would like to talk about is Ducano. So it is free, it is open source, and you have this option to install it via pip, Docker, or Docker Compose. And it has cool features. For example, it supports collaborative annotation, multi-language support, and it also has emoji support. Next slide. Here you would see a snapshot of the task that we created in Ducano for NER task. So the dataset that we were interested to kind of identify symptoms, disease, and drugs. It was quite easy to set up this task using Ducano. And it also gives us specific features. For example, we have admin mode where we would be able to kind of check the label distribution, the project completion, user progress, and annotators.
I think we are reaching the end of our presentation. Awesome. Just maybe one more comment for Ducano. I think Ducano is really good to use when you are just trying out your NLP project, trying out some NLP tasks, and you want to have a really quick and easy solution to annotate your data. It's very, very simple to use. You can import your data in JSON or TXT. You export your labels in JSON or TXT with the start and an index, for example, for entity extraction. we just started an index of that entity and the text itself. And you can also upload, if you already have annotated data, you can upload that and it will display it annotated in the Kano itself. And you have basically 3 different roles that you can have. It's either admin that basically sets up the project, can upload the data and reviews can label the data and reviews the labels and see kind of statistics around how many annotators annotated, how many segments, etc. Then you have the annotators itself. So they don't have access to labels that did not label themselves. And then you have annotation reviewers. So they are basically, that's that QA team that we talked about that goes and basically reviews if what was annotated was actually correct. Maybe they can remove some annotations, add some annotations. So basically those are the three different roles, and you can easily split your documents into, or the text segments into batches and upload them separately, and basically delegate the work between the annotators and which annotator does which batch. So this is something that we would definitely recommend if you're just starting and playing with some tools. This one is free, so it's really a good way to start with the data annotation. So yeah, here we go. Thank you so much. We are happy to answer any questions that you might have.
I can see that there's one question related to when there was bias in annotation. In my example, gender, how did you work around it? I think sometimes bias is, you can kind of escape from it, but sometimes there is no escape. And I believe kind of it also depends on how you do, right? How you do the annotation. So if you're using crowdsourcing platform, sometimes you have less flexibility, right? In my task, what I did was asking questions from the annotators in the beginning. So for example, if English is their first language, what is their gender? Did they have any experience of harassment with themselves or their kind of relatives? And I tried to filter them based on those questions and then start the process of labeling task. And it was quite helpful. I hope it answered your question.
So in the case, for example, if the male says that's not harassment, but woman says yes. So how do you deal with this type of, do you consider false positive, false negative, or who has the final guidance, guideline on this one?
Exactly. So I had like some examples that it was actually harassment from the female perspective, but it was sarcastic from the male perspective. Right. So I looked into the social science work, and I had a chat with folks in social science to understand who is the right person to kind of label those kind of tweets. And they recommended me to use female labelers, right? But having like more than, of course, one annotators per tweet.
In the same context, how you do the balance false negatives, because one person says a higher experience of harassment, so his thought process will be a little bit harshness in the tweet annotations. So how you get the balance of the annotation within the even selecting the female size?
So I guess they were we kind of went through different steps. So the first thing, I think we had this possibility to kind of form this task as a kind of range of, how could I say, range of hateful or harassment as well, right? Like from 0 to 10, if it is not harassment at all, 0 or 10, it is completely harassment, right? But it would it would complicate the process. So we decided to kind of look into just these 3 classes to say whether it is harassment or not, filter them based on their background, their gender, and their experience. And the third thing we did was actually, so the process of crowdsourcing was quite fast if the data set is small, but we decided to kind of, how could I say, like use this platform, and we had interaction with the labelers, because there were some kind of examples that annotators, they were confused, or they didn't know which category to choose, right? So they would flag them, and then we would kind of look into those flags.
Okay, so you reduce through the guidance coaching on the continuum coaching over there, right?
Yeah, I guess like what I can say is that we try to be interactive with them, right, throughout the process, and we also gave them like this possibility to flag the items that they were not sure, 100% sure, and we took care of those items that had the flags separately.
Okay. Okay, thank you.
You're welcome.
I'm looking at some of the questions that we missed. So there is a question: is annotation / labeling to create the training set always a completely manual process? So it usually does start as a manual process, but there are some accelerated techniques that you can use to speed it up. For example, as I was mentioning, text similarity. You can use text similarity to even find some automatically find some text segments that you might think that might be annotated, that should be annotated, and just have the QA team or the annotation team just review. So basically they don't have to go and highlight stuff for every single label. They can just say, okay, yes, that was correct. No, this is not correct. Or you can even set up the thresholds for the text similarity. So if everything, let's say between 90 to 100%, you can just automatically, you annotate it as a positive for your task, for your label. But yeah, there is always that human in the loop. So it can never really be, at least for the task that we have experience with and a data set we have experience with, can never really be a purely automated process just yet. So I hope I answered that question. I think it was Anam who asked that question. Then we have a question. What is your personal experience with data augmentation to increase the size of your training data? Yeah, I can. Sima, do you want to take that one? I think you already have experience with that.
Yeah, I have a paper around that. So for like based on my experience, my data set that I work on, it was a small data set, mainly because I guess we had some kind of limitation in terms of the budget. What I did as part of the work was using a knowledge graph like Wikidata and ConceptNet to augment a specific, I would say, words or tokens in a sentence. So if, for example, there was a sentence that, for example, was harassment about a specific token or name, adjective, or verb, I would use ConceptNet to kind of replace that verb, that noun, or that adjective with similar ones. And it was kind of an interesting approach, and it was helpful for my task.
Perfect. I'm looking at another question that we have here. Do you recommend retraining the model after the false positive and false negatives are analyzed? Usually, yes. Usually that's what we do. So after some of the false positives are just really clearly missed. They were actually clearly missed by the annotation process. So model was clever enough to kind of flag that, hey, maybe you missed this sentence, have a look at it. So we do go through the false positives analysis process, but false negative and add it to the training set. But false negatives a little bit more tricky because you need to kind of understand why your model is missing certain examples, certain entities, certain sentences. Usually when that happens, it's either because I did not provide enough training examples of this form of a text or the language. So in that case, we usually have to go back and add more training data, or maybe the type of a label, the data I have that supports this label are just too variable, very inconsistent. So again, I have to go and add more examples for the model. So we do usually retrain after this analysis, and it's really an iterative process. Yeah. I think we had the questions about annotation tools. I think so. What we are currently using is we are exploring the vertex labeling tasks. We are using GCP and Docano as well. Then we have a question: should the multiple annotators each annotate the whole data set or have a percentage overlap? Sima, do you want to take that one?
Sure. So I think I missed the first part of the question. What was
it was whether multiple annotators each should annotate the whole data set. I think I can respond to that one. So we usually don't have annotators annotating a whole data set. We split it into batches. So the annotators are assigned specific batches of the data set for the annotation. And maybe if they are also doing the QA, they would QA a different batches that someone else annotated.
Yeah, exactly.
But we always have at least the minimum 2 annotators annotating the same batch. Ideally, it should be more, because there is a lot of ambiguity usually in text, and it's not that if one annotator is this way and the other annotator annotates it the other way, that one of them is wrong. Maybe this is just because it's just not clear how the text should be annotated, and maybe we need to go back and update the guidelines, for example. Then we had a question: which library contains these metric functions? Which metrics are in particular that you're interested in? It was Chengyin.
I guess like in scikit-learn, we have different libraries for each of the matrices, like quants kappa, place kappa. There are also some kind of GitHub repositories that have like all of them. So all you need is to kind of identify what is your task, and they would kind of show you the result. So I guess there is one question: have you used active learning approach to optimize annotation process? For my task specifically, I didn't use, but I know right now, like there are some kind of annotation tools that they use active learning in the background. So there's no need to kind of, as a user, to deal with this process. There's also another question. Hi, Veronika and Simon. My question is, how do you decide which task to fall back to when your model evaluation does not meet your expectation? I guess for my task, the first thing I do is usually attacking false negative and false positive, looking into the examples, and then decide based on those items what is the best thing to do. It really depends on the task, I would say.
Yeah, it does. And yeah, so when we need to go back to data annotation, I think I mentioned a couple of situations when I see that, for example, I'm having too many false negatives coming from my model for a specific label, then I know that probably I need to annotate a little bit more data for this. If I see that when we tend to go back to research is when we see that for example, our techniques are just too heavy. Our algorithms are too heavy for this task. Or maybe it's our algorithms not performing as we would expect across the multiple classes, not just one. So those are situations where we would go back to research. And when we go back to scoping is, for example, I realized that maybe I missed the data source. So I have to go back, or I kind of didn't have the right intuition about how much time I will need to get to certain model performance that would be acceptable by my stakeholder. Sometimes even the problem definition might change from the stakeholder coming directly from the business. So that in those situations, we would even go back to scoping and problem redefinition.
Samples for assessment. Language level. So there is one question about Docano. I might not be able to understand it very well. What do we refer here by language level?
What do you mean by annotation as tool for pre-screen or automatic marking?
Yeah, I guess like this question is not very clear. Like annotation, like process of annotating is usually an expensive process, right? Like in terms of the time, money. So even if we are using it, I think it should be justified in terms of time and money, right? As part of grading or marking.
You mean automatic grading or marking of the annotations?
Yeah, it's still not clear for me, Veronika.
Yeah. I think, yeah, we probably don't have that much experience with that in terms of Docano. But we can certainly have a look into that and get back to you on that. So we had also a question. Can you maybe talk about the sampling techniques that you have used to select different samples from the dataset effectively? Random sampling have potentials to sometimes miss the important record sentences text. Yes. So one of the information that we do use when we sample randomly to even find the initial sample data set for analysis is, as I mentioned, we look at the metadata. So I try to add, let's say, variety of file sizes into my data set. I work closely with the stakeholders and with the people who have knowledge about the data source itself. So I have a couple of examples and I worked with the big data sets in the legal space when we did really need to have that input from the business that would tell us, hey, in this area, in this data source, we'll provide you this type of data, this type of agreements, and we know that the big file sizes should be the ones that have this particular information. So we use it's partially automated, it's partially working closely with the business to identify from which data sources in which data sources the relevant information sits. It varies from labels to labels, it varies from tasks to tasks. So we use the metadata information. We sometimes even compare it. For example, if we do have the bandwidth to compare the text versus our vocabulary, we even do that. And we add maybe examples across files that have that cover 80% of our vocabulary, that let's say cover only 50%, only 30%. So we want to understand why is that. So there's various steps that we can take. Then we have a question. Are all annotators data scientists? They actually usually are not. So when it comes to medical text, for example, we do often need to work with the subject matter experts and not the data scientists. From my experience with the legal text, we used to work with the lawyers who would help us annotate the data, because data scientists a lot of times don't have the domain knowledge, don't know exactly what needs to be annotated and what not. But I do have experience with situation where data scientists were annotating data when it comes to something very clear, like, for example, annotating names in text or as an entity, or annotating our phone numbers as in text. If it's something very clear how to annotate, we do sometimes use the data scientists, and sometimes we don't need the subject matter experts. Yes, so many times that is the problem. The expensive, yes, the annotation process can be expensive. That's why it's very important to understand. We go back to the beginning of the machine learning model lifecycle. What is the business problem definition? You have to understand what your business impact is of your project, of your tool, or of your solution. So you need to understand. Okay, you need to invest something into this to be built, but you potentially might have a big impact and big savings or big revenue jump for your company. So in that case, yes, even if it's an annotation a little bit more expensive, you need to kind of balance it out between what you're getting out of the solution.
How you define upfront cost when you have to balance your total algorithm model generation cost? How you define the cost calculation? So
we usually, if you're hiring people, like for example lawyers to annotate your text, or medical specialists to annotate your text, they have their own value that you need to pay for them, right? So you need to the cost that you have of the annotation team. So you kind of estimate how many annotators you would need for your task. And you estimate the cost. That's the annotation part, and for how long you're going to need them. And then in terms of the model building, it's also mostly about the infrastructure that you need and computational power that you need. So as long as you can kind of estimate the timelines, the time frame that you need for building the model, you can estimate the cost approximately for building the solution, including the computational power and the resources that work on this.
Thank you.
I think we kind of went through most of the questions.
Hi, Veronika.
Yeah.
This is Rana.
Sorry, we have one more.
Sorry for interrupting. So I just had some question on the similar lines, actually. So what the quality of the annotators. So if we were to incorporate the experience, suppose one annotator has spent a lot of time doing one particular task, and one other annotator has not spent as much time. So do you have any ideas on how to incorporate that experience into your quality of evaluations for quality?
So we actually did have this kind of situation in my past projects. We kind of have it really depends on the experience of the annotator. So we had the annotators that would annotate the text quickly and the good quality. Then you have annotators that annotate quickly, but maybe not as a good quality. And then you have annotators who are very thorough, and they go through basically every single examples very, very thoroughly to make sure that what is annotated is just clear as it should be. So usually we have the first and the second. It's mostly, that's most of the annotators that we have are really fast. When we have the slower annotators, we usually tend to give them maybe a little bit simpler task to annotate, to kind of see if that can speed up the process itself. So we really even the task, or even the annotation labels have a complexity. For example, if I just annotate, if I'm just annotating the names, or I don't know, symptoms, or something like a maturity date in the contract, that might be easy enough. But if I'm annotating, so I give this to maybe annotators that I know that they need a little bit more time. And if I have examples of the tasks that are very difficult, and it needs you require, for example, read a whole section of text to understand what needs to be annotated, then we tend to give this to more experienced annotators.
Okay, thank you so much.
Just building on that, great tutorial, by the way, thank you. What do you do if the annotators disagree? How do you reconcile which annotator to trust?
Yeah, so I think Sima is probably better to answer this question. She has more experience with the different techniques. But from my end, what we used to do is just look at maybe what is like the voting system. So like what the labels are the most frequently annotated. And sometimes we would go with that. Sometimes we go back and investigate, okay, so why do they disagree? And even as I mentioned, as we were sitting and directly communicating with the annotators, we would discuss, and we would try to see the point of view that the annotators might have, why this should be annotated, this shouldn't. And based on that, we make the decision. But I know there are also techniques how you can kind of bake the weights into the model based on how many annotators annotated this example as positive. So then when you are evaluating the model, and some label, for example, didn't have 100% coverage from the annotation, from the annotators, the probability that is coming out of the model with which this label or this text is relevant might be also lower, but it doesn't mean that I don't take it into consideration. So the kind of there are techniques how you can put the weight into the model based on the annotation coverage. And Sima, do you want to add something from your experience?
I think what you mentioned is absolutely right. Like with all of these kind of matrices, we also have the weighted version of them, like weighted Cohen's kappa or Flace kappa, and they kind of help with annotation process and help trusting which annotators more. For my task, personally, what I did was I kind of separated the data set into kind of different chunks of kind of manageable chunks, maybe like 20 to 50 tweets. And I had this possibility to kind of filter annotators based on the specific questions and the backgrounds. So it was easy for me to kind of understand like which chunk has a good annotation quality and how is it kind of far from, for example, or close to the domain expert annotators, right? So I think they were the things that I used, yeah.
Okay, thank you.
So we have a question around zero-shot or few-shot methods. We actually didn't try those. That's something that is actually on our roadmap to try to bake it into our annotation process. So that's a good idea. And then we have a few actual applications in terms of annotation NLP in Canada and the world. Thanks. We did have projects that that were specific to the annotation on the data and a Canadian data sets. So there are, of course, in the legal domain, there's so many applications when you really want to, for example, extract the extra specific topics from the legal agreements, identify specific clauses that will talk about specific topic. I worked on a program when there were new, let's say, new regulatory changes brought into the processes, and suddenly financial institutions need to go through the repapering process, for example. So they need to kind of go through all the documentation and create amendments because certain clauses are not applicable anymore because of the regulatory change. So in that case, you really have to go through the process of how do you find, first of all, how do you find these documents that need to be repapered or amended? And then once you find them, okay, you need to find the clauses that need to be amended. So that is one application. In terms of what we do at Loblaw, we do work a lot with the textual data in order to help with the customer support. So more efficiently analyze the questions, the concerns and feedback from the customers. Have I answered the question? I don't see any new questions. Maybe I missed some.
Yeah, no, I think we're good, Veronika and Sima. Okay. Thank you so much. I really appreciate it. This really encapsulated everything that I hope for in these workshops. A lot of questions, a really cool, interesting use case that's practical, that shares, that allows people to ask a lot of questions, and you've been very generous with your time. So I'm very, very thankful. Thanks for all the great questions for those in the audience. I hope you enjoyed it. And we have another workshop kicking off this afternoon. And then as well, tomorrow on the Hopin platform, we'll be hosting various speakers. One quick mention before we depart as well. Please note that in November, we are going to be running our annual event. So that will include 3 days or 2 days of workshops, 2 days of conference talks, and some other special little surprises along the way. So if you haven't had a chance, we'll be announcing that to via email with an invite. That's our annual November TMLS Summit. So with that being said, thank you again, everybody. Thanks, Veronika. Thank you, Sima. I really appreciate it. I hope you enjoyed. For those who haven't caught this or you had to cut out, don't worry, you could review the literature afterwards and the video afterwards if there's some things you want to catch up on. Otherwise, we'll leave it at that. And I hope you enjoy the rest of your day. Thank you, everyone.